Dependent variables and independent variables. Welcome back. In the next couple of lectures, we are going to build a probability of default model, a loss given default model, and an exposure at default model. All of these will be regression models. For the PD model, we are going to use a logistic regression, while for the LGD and EAD models, beta regression. These models will help us predict our outcomes of interest, also called dependent variables. The rest of our variables are the ones containing the information we will use to predict the dependent variables. These are called independent variables, predictors, or features. Let's outline what our dependent variables are going to be. For the PD model, we'll need an indicator, or a flag, whether the borrower defaulted or not. As we suggested in our previous lecture, the loan status will help us with that. For the LGD model, we'll need to calculate how much of the loan was recovered after the borrower had defaulted. This information is contained in the recoveries column, so that will be our dependent variable. Finally, for the EAD model, we must calculate the total exposure at the moment the borrower defaulted, compared to the total exposure in the past. You can find relevant information in the total recovered principal column. Of course, we can use all other variables we have. However, they will require a lot of pre-processing. Depending on the type of data, discrete or continuous, we will have to apply different pre-processing techniques. For our purposes, we'll distinguish between two types, discrete and continuous. Discrete, or categorical variables, take only a certain finite number of values. Continuous, or numerical variables, on the other hand, can take any value in a given range, or in other words, they can take on an infinite number of possible values. To complicate our task even more, some variables take discrete values but can be treated as continuous variables. In our dataset, the number of credit inquiries in the last 6 months is an example of such variable. The number of inquiries itself is discrete, as it can take on values like 0, 1, 2, 3, and so on up to 20, 30, or even more. Since there is a sufficient number of ordered discrete values, we will be able to treat the variable as continuous. Even if it sounds overwhelming now, we will be going into great detail through each of the different pre-processing techniques, so don't worry. Okay, a distinctive feature of the PD model is that all of its independent variables have to be categorical. The reason is that it is much easier to present the model in a simplified form and turn it into a scorecard if we have only categorical variables as predictors, rather than having both categorical and continuous variables. Therefore, the pre-processing for the PD model will consist in transforming all independent variables into suitable categorical variables, or dummy variables. To aid us a bit, there are variables that are discrete already, like verification status. The pre-processing there would be simply to create dummy variables for each of their original categories. However, some of these discrete variables may have too many categories, or the information they hold about the differences between defaulted and non-defaulted loans across some of the categories may be negligible. In this case, we will combine 2 or more categories into a new category, ultimately aiming to reduce the total number of variables. One example for this operation is home ownership, as very few of its categories will make a real difference. Only when we've reached a final version of the categories, we will proceed to creating dummies. Okay, continuous variables like annual income and number of credit inquiries in the last 6 months will also be transformed into categorical dummy variables. However, the procedure we will follow is different. We will start by turning each of them into meta-categories of equally sized intervals. Let's take the number of months since the loan has been granted. For example, we will slice it into 50 intervals, like 1 to 3, 4 to 6, 7 to 9 months, and so on. This operation is called fine classing. Once we have created these intervals or classes, we will explore how well each of them discriminates between defaulted and non-defaulted loans. Similar to our discrete variable preprocessing, if two adjacent categories discriminate equally well, we are going to merge them, while if the next category discriminates a lot better or a lot worse than the previous one, it is going to be part of a new variable. For instance, regarding the feature months since the loan has been granted, we may end up with the categories less than 1 month, between 1 and 2 months, between 2 and 12 months, from 12 to 24 months, another one from 24 to 27 months, etc. There will be no need for those intervals to be equal. This procedure is called coarse classing. There are very rigid rules to these operations, and we will get very good at performing them. Of course, there are other considerations that come with experience when deciding how many of the initial categories to merge into new ones, but we'll look at those later in the class. We will finish off by creating dummy variables for all final categories we have decided to put in the model. So, this is our reasonably detailed plan for the pre-processing part. In the next lecture, we will actually import our dataset in Python and start pre-processing. Thanks for watching.